Okay. Online voice. Let's see now. So what we'll discuss? We will discuss about Bellman-Ford. See here, everyone. Observe here. Okay, we will discuss about Bellman-Ford. Bellman-Ford. Okay. So what is this Bellman-Ford algorithm? Is nothing but here we will going to have a graph. Please understand properly. We will going to have a graph. In that graph, what we have to find is we have to identify the shortest path. We have to find the shortest path. Okay, so this is what we have to identify. Okay, basically we understand very clearly about Dijkstra's algorithm. Dijkstra's algorithm we understood, right? Now you see everybody, I will take one graph, simple graph I will going to take, simple one graph I will going to take. Let's take a graph. The graph is like this. A. Okay, now again here. Okay. I will make it a little bit bigger. Here I will take A, B, again one more I will take C here, again D here. Okay, so these are the vertices. Fine. A to B I will going to have a connection. So now when you see such kind of direction, it is called it as directed. Okay, again from B to D, please observe here, from B to D I have a connection. Okay, done. Again from C to D, here from C to D I have a connection here. Over. Again from A to C I have a connection. Okay, done. This is nothing but indicates very clearly it is a directed graph. Over. It is a directed graph. Again we have a path, that is called it as one more path from B to C. So that is one more path. Again from C to B, one more path we have here. See here, one more path. Done. So all this, everything is done. Finally I will going to call this graph G is equal to V comma E. Okay, G is equal to V comma E. This graph is a directed graph. One thing, first thing. After that, see here, we need to have a directed graph. Again one more thing, we have to have a weights. If you want to find the shortest path, you must have a weights. So that's why I will going to provide the weights, that is 10 here, again one more 5 here. Okay, again one more 7 here, again one more 50 here, again one more, this one you take it as 60 here, again here one more you take it as minus 48. Okay, so these are the weights. Sir, I understood everything, whatever the things you said. Now what I have to do, sir? Okay, Bellman-Ford says that very clearly. You have to use the technique. Okay, you have to use the technique. What kind of technique? That is called it as edge by edge technique. Edge by edge. Please understand this. Edge by edge. Okay, now that's it. Edge by edge you have to do. Now sir, you said very clearly edge by edge. What I have to do now? Nothing. No need to do anything. Take something. E1 is the edge 1. Again you consider this one as E2, that is edge 2. Again consider this one as E3, that is edge 3. Again you consider this one as E4, that is edge 4. Again consider this one as E5, that is edge 5. Again this one finally edge 6. Clear? Now everything is done properly, everything is done perfectly. Oh sir, I understood. You provided the edges also, you provided the vertices also, you provided the path also, everything is provided. Now in the when they are giving Bellman-Ford, what they will going to do, where you have to start, which is the source they will going to provide. Okay, source they will going to provide. So consider here I will going to provide the source as A. This is the source. I will going to provide the source as A. Please understand this one right now. Please understand. Sir, what is the difference between Bellman-Ford algorithm as well as Dijkstra's algorithm? Very simple. What is this Bellman-Ford algorithm? What it will do? Basically, Bellman-Ford algorithm, okay, if you have a negative weights, okay, the edge, if I having a negative weight, you can able to see minus 48. This is a negative weight. If you having a negative weight, automatically what it will understand, it will going to understand very clearly, I cannot able to apply Dijkstra's algorithm, I can able to apply Bellman-Ford algorithm. That is what the meaning is. Whenever you will going to find something like this, please understand, whenever you will going to find something like this, what is that exactly? If you find negative weights, immediately you have to understand, I have to apply Bellman-Ford. That's it. Okay, na? If you are finding negative weights, just no blindly you go, okay, I have to apply Bellman-Ford. Okay, sir, why not Dijkstra's? Dijkstra's, because the reason is it may give answer, it may give wrong answer. Okay, it may give right answer also, it may give wrong answer also. But Bellman-Ford is a good algorithm only for when it is a positive edge weights. Understood? Sorry, Bellman-Ford is only for negative edge. Okay, but Dijkstra's algorithm for only for positive weights. Okay, this much you have to be very clear. Okay, you have to be very clear with these points. Now see everyone. So what is this exactly? When you go to the Dijkstra's algorithm, every time when I do, okay, whenever I will do the procedure, what I will going to do, every time I will going to delete the vertex. But here it is not like that. So what we will going to do here, point number 1, we will going to relax all the vertices. Relax. Okay, so relax all the vertices. Okay, so what we will going to do, each vertex A, B, C, D is there now. One round we will going to relax all the vertices. This is the first thing you have to do it. This is the first thing you have to do it. Okay, understood everyone? Now please everybody assume here. Please everybody assume here. Please everybody assume here. So this is the source. Again, for this source I am taking a new value. For this source I am taking a new value, that is 0, again null value. Okay, now 0 and null. This is the value I will going to take it. Now okay sir, we understood everything. So how to implement this one? See here we have a Bellman-Ford algorithm. So algorithm, how the algorithm works I will tell you. We have a Bellman-Ford algorithm. How it will work sir? Basically take one array. Please understand, take one array. Okay, so whatever the vertices are there, see here A, B, you can call it as U, V, all those things. Whatever the vertices are there right now, okay, all those vertices must be inside the array. For that what I will going to see, what I will going to do, just observe this one. What I will going to do, just observe everybody. See now. Okay, now what I will going to do, see here everyone, this is an array. Okay, this is an array. Here I will going to take the vertex A, again I will going to take the vertex B, again I will going to take the vertex C, again I will going to take the vertex D. How many vertices are there? 4 vertices are there. I taken 4 vertices. That is done. So what is this, where these vertices are available? These vertices are available in present in, see here, present in array. So where it is available, all these vertices are available in array. Okay, so we have given the name. First step, what you have to do, initially what you have to do, see we have taken the source is 0 right now, source value, source vertex value is 0, but from A to B we don't know exactly whether the path is there or not. We don't know exactly. So even we don't know whether path is there or not. We don't know. So that is the reason why what we will going to do initially, please understand, initially, so everything you make it as infinite null. Okay, here also same, infinite null. Again here also same thing, infinite null. Okay, na? Understood everyone? Everyone clear with this? So first you have to do this one. So write here, same thing you write here. So what is the value of A vertex? That is 0, null here. Again B vertex, what is that? Infinite, null here. Again infinite, null here. Again here also infinite, again null here. Okay, this is the first thing you have to do. So that is done actually right now. So I think everybody okay with this, right? Everybody okay with this. Now see here, so first is over. Now See, here there are 4 vertices are there. Here there are 4 vertices are there. Here there are 4 vertices are there. These 4 vertices, okay, help us to identify the shortest path. Okay, how? So basically, to get the shortest path here, to identify the shortest path, so what we will going to do, basically in Bellman-Ford, so we will going to do some rounds here, nothing but iterations we will going to do. So many iterations we will going to do, that is called it as rounds here. So for 4 vertices, how many rounds we have to do? Suppose think like that, I wanted to visit each and every vertex. Suppose A to B, again B to D, again D to C. That's it. Three paths are more than enough to visit all the vertices or not? That is what exactly. Same thing like that as well. A to B, again B to C, again C to D. Only 3 paths are more than enough to visit all the vertices. Yes or not? That is what the idea is all about. What is that idea? Is nothing but number of vertices minus 1. Okay, so that will give you the shortest path. Okay, na? So how many vertices are there? Totally 4. 4 minus 1, what is the shortest path? 3 path it will be given. So that is what you have to understand. This is also very, very important. So it indicates very clearly so shortest path we will going to get it. So the what is the path length is 3. So nothing but 3 rounds is required to get the 3 rounds is required, okay, to get the shortest path. Clear up to here? Clear everyone? Okay. So this is what, that is the reason why this one, that is the reason why this one. Okay, now now see, so what I will going to do, first one, everybody please observe here, everyone please observe here one by one. Now you will observe here. So what I will do, first one, round 1, okay, now again second one, round 2, okay, now again round 3, okay, now we will see further verification. If you want to do, I will do. So here what I will do, round 1 I will do, round 1. Okay, now round 1 I will do. What is that round 1? I value equal to 1. Again round 2. Okay, what is that is equal to? I value equal to 2. Again round 3. What is that equal to? I value equal to 3. That's it. Understood everybody? Everybody understood now? Very simple. Easily you can able to do everything. Now okay, everything is fine. Everything is ready now. Everything is ready. Let's start now. Let's start now. Everybody observe here. A is having, what is the current value of A? 0 and null. Yes or not? 0 and null. So current value of A is 0 and null. Now we don't know what is the path for to visit all the vertices. That's why infinite. Infinite is nothing but what? Greater value. Greater value. Infinite is nothing but what? Greater value. Maximum value. Infinite. Yeah, that is the reason why it understands very clearly. Maybe infinite path is there. Okay, the value of the path is infinite, like that it will feel. Now A will going to say, please understand everyone, A will going to say it will going to give the offer to B and C, all those things like that. But one thing you need to understand, so when you are doing the Bellman-Ford algorithm, here observe here, when you are doing the Bellman-Ford algorithm, please follow this. Please follow this. What is that? Edge by edge. Edge by edge you are to follow. Sir, how to do this one? What is the edge 1 here right now? So what is the edge 1? E1 is, what is that right now? Exactly. So E1 we have, this is following C to B. It is traveling from C to B. Edge 1 is, what is that? Exactly. C to B. What is the C value? Infinite. What is the C value? Infinite and null. Yes or not? C value is infinite and null. Infinite plus 7. What is this value will become? Infinite plus 7. Who is giving? C is giving. D says that, C will going to say very clearly, hello D, I will give you one offer. What is the offer you will going to? D will say that, hello, already I am infinite. What offer you can give? Still C will going to say, I will give you one offer. What is that offer? Short path I will going to give. Infinite plus 7. D will says that infinite plus 7, that is more. Don't say. Okay, not required, like that. Understood everyone? Everybody clear? So now, okay, that is E1. First edge you have to start, that is E1. So here we have a infinite, please understand, infinite, nothing but U value, actually U plus V, infinite. infinite plus 7, what is the value it will become? D value will become, what is that? Infinite plus 7. Again, who is giving this? C. But infinite plus 7 is what? Greater compared to infinite. Yes or not? Greater compared to infinite. Nothing but what? It should be small. Okay, whatever the value you will going to receive here, it should be small. So that is the reason why it will going to reject. No, I don't want this. Okay, na? No, I don't want this, like that. It will going to reject. So nothing but what I'm saying exactly here, please understand what I'm saying exactly here. So if it is infinite, don't change anything. If it is infinite, don't change anything. Okay, done. This is over. I can go to the vertex E2. See here, edge E2, sorry, edge E2. D from B to D we are going or not? From B to D we are going or not? Yes. So what is the B value? That is infinite and null. Okay, it says that to D. So I will going to give you infinite plus 5. You can change it. It will says that no, already I am maximum. No need to go become more bigger. Okay, this is also over. E1 is over right now. E2 is also over. Go to the E3. Again, infinite plus 60. Okay, it will become, C will become what? More than infinite plus 60. It will going to reject that one. I don't want your offer. E3 is also over. Again, go to E4. Now see here, what is the value of A? That is 0 actually. What is the value of A? That is 0 actually. 0 plus 10 compared to infinite, 10 is better or not? A will going to say, hello B, I will going to provide the shortest path. I will going to provide the minimum. Okay, I will going to provide the minimum path. So it will says that, okay, B says that, okay, what is that offer? Offer is, I will give you 10. You have infinite, but I will give you the 10. Okay, B will says that, then I am very happy if you are giving the part 10. So it will take 10. Who is giving this value? Here you have to do like this, 0 plus 10. Okay, 0 plus 10, what is the value? 10 you will going to get it. Hence before B having infinite, 10 is. This technique, please understand, this technique we will call it as relaxation, edge relaxation. Understood everyone? This technique we will call it as vertex relaxation. Before it was infinite, now what we are getting? We are getting 10. Who is giving this one? A. That's it. Understood? Understood everyone? Okay, so this is what you have to understand. Please understand, this is what you have to understand. So we are doing the, how we are doing? By decreasing key. What is the key here? Infinite is there. What is the key here? Infinite. Key value is infinite. So we are doing the relaxation using decreasing key. So key is decreased or not? 10A. That is what you have to understand. So E4 is also over. Again, what is left is E5 is there. Please see here, from where to where it is going? C to B. Okay, what is the value of C? Infinite plus minus 48. Okay, infinite minus 48, it will become more or less. Yes or not? So that's why it will not going to change. Here also it will not going to change. Please understand. Okay, clear everyone? Again, now see here. Again E6. Please observe E6 here. E6 here. 0 plus 50. What is the value? Compared to infinite, 50 is better or not? So that's why it will going to change. 50. Okay, null. So this will cancels. These things are cancels. These things are cancels. Here also cancels. You got the value 50 and null. Now one round is over or not? Please observe here, everybody. One length path is over or in this 3 minus 1. See here, in this 3 minus 1, 2 rounds are left here. One length path is over here. Please understand. One length path. Okay, one length paths are covered or not here? See, observe here, one length paths are covered or not? Okay, one length paths are covered. Now you check all the vertices, whatever the updated values is there, please write down here. A is, what is the value? 0, null. Okay, what is the B value? 10, A. Again, what is the C value? Here, sorry, this is A guys. I am sorry for this. This is A. Again, what is the C value? 50, A. Again, what is the D value? Infinite, null. That's it. This is round 1. I think it's clear. Again, if you are able to understand this one, so this is okay. This is okay, fine. How much time you have taken? Please understand how much time you have taken to change this key, decrease key. Change this decrease key is nothing but relaxation. Nothing but you have relaxed, right? Okay, you have relaxed this edge, you have relaxed this vertex. How much time you taken? I have taken e, okay, into, please understand this one, e into big O of 1, constant I taken, constant value I have taken. Edge is required or not? Edge into constant value. Okay, so this one you have to understand. Everywhere same thing you will going to get it. Now round 2, please go to the round 2. Okay, round 1 is over already, go to the round 2. Take even edge. Everybody see here, even edge is there. Everyone see here, even edge is there, yes or not? So from C to D, we are going from C to D. Okay, what is the path? C to D. What is the value is there? C value 50a. Please understand here, 50a is there. 50 plus 7, please understand, 50 plus 7, what is the value you are going to get it? Instead of infinite, so you will going to get the value 57. Who is giving this one? C. Okay na? Who is giving this one? C. I will write here pa 57 C. Who is giving this one? 50. C is giving. So value is updated or not? Value is updated or not? This is also over. That is over. Okay. After that, you come here. B. Okay. So E to edge. You check it. B to D. See here, B to D. Observe here, B to D. So what is the value? B value, that is 10. Yes or not? What is the value? B value, that is 10. So 10 to D. Nothing but what happens here? 10 plus 5. Please observe here, 10 plus 5. Please observe here, 10 plus 5. What happens? It will become 15. This is also over. It will become 15. Who is giving this one? B. Okay. Who is giving this one? E2 also over. Again come back here. Come back to E3. Now observe here, E3. 10. Okay. 10 plus 60. 10 plus 60. How much you are getting? 10. See, B to C, there is a path. B to C, there is a path. 10 plus 60. How much it will become? It will become 70. So compared to 70, 50 is less. Why should I change? I don't want to change. I will not going to change here. Okay, that is also over. E3 is also over. Come to E4. Check it. Again here, same thing. 0 plus 10. What is the value you are going to get it here? 10. Okay, no need to change here. Again, leave like that only. No problem. Again here, come back here. E4 is over. Again, come to E5. Now see here. 50. See here, everybody. C value is what is right now? C value what is right now? Please observe here. C value what is right now? C value what is right now? C value is 50. Who is giving? A is given. Now see here, C is 50. 50 plus, okay, minus 48. What is that? 50 minus 48. How much you will going to get it? You will going to get the value 2 here. Now you change it. 2. Who is giving this one? C. That's it. Okay, E5 is over. Again E6, same thing. Okay, what is that? 0 plus 50. 50 only we are getting. That's the reason why don't change. This is round 2. Please understand, this is round 2. Nothing but I covered E1, E2, E3, E4, E5, E6. All the rounds I covered. Now check the values. What are the values updated? Now go to the A. Any value updated? Nothing like that. Okay, 0, null. Again, B value check it. It is changed to C. Okay, again C value check it. It is nothing changed. 50A over. Again D value check it. Any changes? Yes, changes is there. 15 and what is that? B. Okay, now same thing here also. How much time it will take to change the decrease key? Nothing but relaxation. Okay, for every vertex we have to do the relax. Okay, that is the reason how much it is taking. Edge into constant time. Big O of 1. That's it. Edge into constant time. Okay, round 2 everybody understood? I think you people understood, right? Round 2. Let's go to the round 3. Please observe here. Let's go to the round 3 now. Round 3. Let's take E1. Everybody see here. Let's take E1. What is the value? 50A is there here. Okay, 50A. 50 plus 7, 57. But basically it is 15 is there. Yes or not? Basically it's 15 is there. See here, everybody observe here. Basically it is 15 is there. No need to worry. Okay, leave like that only. No need to change here. Leave. Okay. Again come back here. B to D. Edge E2 I am doing. Edge E2 I am doing. B to D. What is the B value? 2. 2 plus 5. What is the value? 7. We are getting 7. Change it. 7. Who is giving this one? B. Change it or not? Okay, edge 2, when I am doing edge 2, it is changing. I can go to the edge 3. What is the value? 2 plus 60, 62 compared to 50. 62 is greater. Don't change, don't change. I can come back. Okay, okay, e2 is over, e3 is also over. Go to the e4. 0 plus 10, what is the value? Okay, 10. Okay, so it will basically, it is 2 already, so it is compared to 10, it is lesser. Don't change. Okay, e4 is over. Again go to the e5. 50. Okay, same thing. 50 minus 48, what is the value? 2. Don't change anything, don't change anything. Okay, keep it like that only. Again a to c. 50 plus 0, same value you will going to get it. Yes or not? Same value you will going to get it. Leave like that only, don't change. Now what is the updated values? You update. So a value 0 null, b value check it 2c. Yes or not? 2c. Again c value 50a. Again d value 7b. Okay, d value 7b. Same thing. How much time it is taking? Edge into big O of 1. Okay, this much time it is taking. Clear everyone? Everybody clear or not? See, everyone clear or not? This is how you will going to find the shortest path. Okay, shortest path for Bellman-Ford algorithm. Very simple, very simple. This is the way you have to do it. This is the way you have to do it. That is what exactly. See here, from B to C. Okay, what is the path you will going to say? Okay, 2. What is the path you will going to get it? B to C. B to C. Check it here. 2 you will going to get it. Yes or not? B to C. Here you can able to see B to C. So from B to C, 2 you are getting. Again C to A. C to A. C to A. Okay, you are getting the value. What is that? 50. Again D to B. What is the value you are getting? 7. That's it. This is the shortest path. This is the shortest path, you will going to get it. Okay sir, we understood very clearly about this one. Sir, I wanted to know whether this one is giving right answer or not. Very simple, just verify. Just verify. Just verify one more. So one more time you do the iteration, that is I4. Okay, you do one more round number 4 to verify. Check it now, everyone check it. Oh, even same thing 50a. Okay, when you do this one, whatever the value is there, 7 by b compared to 50, this is less. No need to change. Again here same thing, you check it. B to d, 2c plus 2 plus 5 7, same thing you are getting. Don't change it. Again e2 is over e3, check it. 2 and 50 compared to this one, this is smaller, 2 is smaller. Don't change anything here. Again come to here. Okay, e4. 0 plus 10 compared to 2, 10 is greater. Don't change here, again a to c, sorry a5. Okay, 50 minus 48, e2, same thing only. Don't change. Again a to c, 50 plus 0, what is the value? 50. Nothing is changing here, please understand here, nothing is changing. Same thing, 0 null. Again 2c. Okay, again 50a. Yes or not? 50a. Again d value 7b, you are getting nothing but if you are getting the values like the same values, if you are getting, it indicates very clearly. So we got the shortest path. Okay, nothing but what I'm saying exactly, there is no chance of 4 paths here. There is no chance of 4 paths. 4 paths are not required to visit each and every vertex. 4 paths are not required to visit each and every vertex. 3 paths are more than enough to visit each and every vertex. Again one more thing. So what I am doing, I am using array. I am not using min heap. No min heap is used here. Okay, no min heap is used here. That is the reason why this one. That is the reason why these things. Okay, again one more thing. Sir, okay, we understood everything. What about time complexity? Time complexity is equal to big O of, see here, everybody, time complexity is equal to big O of V into E. Okay, now V into E. That's it. So that is the reason why you are not getting log here. That is the reason why min heap is not there. That is the reason why you are not getting log here in the time complexity. So this is what exactly you need to understand. Okay, now this is what exactly you need to understand. Okay, this is all about Bellman-Ford algorithm. This is all about Bellman-Ford algorithm. Okay, so one more important thing you need to understand here. Please observe here. So Bellman-Ford algo and Dijkstra's algo. So what is the difference is nothing but this is for negative weights, this is for negative weight, this is for positive weights. Okay, this is for negative weights, this is for positive weights. This one also give, this one also may or may not give, it will going to give the answer may or may not, may or may not. Okay, this one also give the answer, but possibly, so if it is negative, use the Bellman-Ford, use the Bellman-Ford, not Dijkstra's, not Dijkstra's. Okay now, everybody clear with this? I think you people are okay with this, yes or not? Yes or not? You people are okay? Now see here, one more important thing you need to observe here. Okay, one more important thing you need to observe. I think you people are clear with this. Now, so what, there is a one problem in this, there is a one problem with this. Okay, Bellman-Ford, there is a one problem in the Bellman-Ford. What is that Bellman-Ford problem is? Suppose take a graph like this, A, okay, from A to B, okay, again B to C, okay, again C to D. Okay now, so from B to C, again C to D, C to B, again C to D. Okay, this is the graph. Take this one more example. I am talking about one more example. Example number 2. Take it 2. So edge weights I will going to give you. So something like 10 is there here. Okay, so you take 30 here, you take 40 here, again you take minus 38 here. Okay now everybody observe here, everybody observe here, this is the graph right now we have. So what happens here, basically see here, from A to B I am moving, from A to B, again I will go from B to C, again C to D. So what happens here, 30 plus 10 it will become 40 here. Okay, here it will become 40 minus 38. Please understand here, 40 minus 38, what it will become? To visit the B, what is the, how much path length it will take? It will take only 2. It will take only 2. Okay, so what happens here, there is a negative cycle you will going to find here. This one also I will going to do, don't worry, this one also I will going to do. There is a negative cycle, you will going to get it. Basically there you are not going to find any changes, yes or not? Always you are getting the positive values, always you are getting the positive values. Here what happens, basically you will going to get the negative values. Okay, here also same thing. How many vertices are there? There are 4 vertices are there. What is the path length is required? 3 is the path length, 3 is the path length is required to get the shortest path. Okay, again one more important thing, what is that exactly? Oh, what is that exactly? Rounds. How many rounds is required? Only 3 rounds, only 3 rounds. Okay, only 3 rounds are required. So let me show you how it works. See here, everybody observe here now. Okay, so what are the vertices? A, again B, let's write here only B, C, again D here. Okay now, initially what I told you, just put everywhere. Okay, for this one 0, null. Okay, null. Again this one infinity, null. Here also infinity, null. Again here also infinity, null. Okay, understood? Now you people tell me, A to A, if I am visiting from A to A, what is the value you are going to get it? A to A, I am talking about A to A. What is the value? That is 0. Yes or not? That is 0. Okay, like that. A to B, what is the value? Right now it is 10. In future it may change. Okay, B to C, what is the value? 30. In future it may change. C to B, what is the value? 38. In future it may change. C to D, what is the value? 40. It may, in future it may change. So that is what exactly we have to do. Initially 0, null. Initially 0, null. Okay, initially 0, null. Okay, initially 0, null. Okay, done. Everything is done now. Let's go to the round 1. Okay, again round 2, again round 3. Again here I will do the verification. Okay now, let's do this. So we have taken, now we are here, take edges. Everybody take edges. I will going to take the edges even. I will going to take this an even. Again I will take this one as E2. Again I will take this one as E3. Okay, It is left to you people. How you want it, you can able to allocate, no problem. No, nothing like that. You can allocate how you want it. If you want, you can take it even here also, no problem. E2 here also, no problem. But one technique what we have to use here, edge by edge, edge by edge. That's it. No rule, nothing like that. Okay, no rule, nothing like that. If you take even, you will start from here. If I take even, you will going to start from here. If you take even, you will going to start from here. If you take even, you will going to start from here. Just I taken randomly, I taken. That's it. Wherever you want it, you take. No problem. Nothing going to affect. Same answer, you will going to get it. Okay. Now see, everybody observe here. So first one, what we will going to do? We will going to take the vertices. Okay, from C to B we are moving. Nothing but what is the edge? Even. So what is the value right now here? Infinity and null. Here also infinity and null. So that is the reason why it understands very clearly. No need to change here. Yes or not? Even is okay. Go to E2 infinity null. Here also infinity null. No need to change. Okay, leave it. Again here. So B to C infinity and null. No need to change. I can come back here. See here. There is a value for this. A is a source vertex. Okay, so there is a value 0 and null. Now 0 plus 10, we are changing this one. 0 plus 10, what is that you are getting? 10. Who is giving this one? Here. That's it. Okay, now understood? Now everybody understood? This is what you have to understand. Okay, E4, nothing but what exactly? One round is completely finished or not? E1, E2, E3, E4, all the edges are finished or not? All the edges are finished. Relaxation is nothing but, see, that is what exactly I am telling you. Okay, relaxation is nothing but all edges you have to make it minimum. Clear? All vertices, sorry, not edges, all vertices you have to make it minimum. Vertices, that is what we call it as relax. Okay, I have to relax all the vertices. I relaxed B, still C is left, D is left. Okay, yes or not? That is the reason why you have to relax all the vertices. That is what exactly we have to do. Nothing but see here, 0 null, yes or not? A value 0 null, B value changed or not? See here, B value changed. What is that value? 10 null. Again C value changed or not? No, nothing changes. Infinity null. Okay, guys, these are all infinity. Okay, so infinity null. Okay, done. So this is what we call it as round number 1. R1 I will want to consider nothing but I is equal to 1. Okay, now round number 1, that is I is equal to 1. Again round number 2 I will take R2. Okay, that is I value is equal to 2. Now see here, so that is also okay, over. Again now observe here, infinity null. Okay, from C to B I am considering even edge. One more time I am considering even edge. I am considering from C to B. What is the C value? Infinity minus 38. It will become more. Okay, compared to this one, this is very less. Yes or not? So that's why no need to change. Yes or not? No need to change. I can come back here. E2 infinity null. Here also infinity null. No need to change here. Okay, leave it. No problem. E3. Now see here. Everyone observe here. E3. So B to C we are moving. Yes or not? B to C we are moving. Yes or not? B to C we are moving. Yes or not? Here 10 is there plus 30 is there. 10 plus 30. What is the value you will going to get it? You will going to get the value 40. Who is giving this one? B. That's it. Relaxation is done or not? Hence before B relaxed, now C got relaxed. That is the reason why we have to do the rounds, 3 rounds. If it is 4 edges, we have to do the 3 rounds. Okay, if it is 5 edges, we have to do the 4 rounds. If it is 7 edges, we have to do the 6 rounds, like that. Okay, 40B we got it. Okay, now 40B we got it. Fine, that's it. Again E3 is over. I can go for E4. Now see here 0 null is there. No need to change. Yes or not? No need to change here. No need to change. Keep it. Now updated values you will want to write now. Updated values, round 2 updated values. That is 0 null. Correct? After that 0 null, 10A, same thing only. Okay, 10A. Sorry, this is 10A. Okay, 10A. Okay, so here 10A. Again come back to C. What is the C value? Here C value changed. Yes or not? 40. Who is giving this one? B. Okay, again D value anything changes? No. Infinite and null. Okay, done. Correct? Everyone okay? Round 2 understood? 0 null, again 10a, again 40b, again infinite null. That is over. Round 2 is over. Let's check with the round 3. Round 3, I is equal to 3. Let's start this one. Okay, see what is the value of c? 40b is there. 40 minus 38, what is the value? What is the value you will going to get it here? 40 minus 38, what is the value you will going to get it? 2 now that is the reason why still you can able to reduce. Okay, who is giving this one? That is c. Who is giving that one? That is c. Yes or not? Okay, done. Now I have to use different color. I will use red color. 2c. Okay, done. So now you got the relaxation. B got much relaxed compared to 10. It got much relaxed. Okay, that is even. Over, done. E2. Let's go to the E2. 40b is there. 40 plus 40. What is that? 80. So this is also relaxed. 80 null. Okay, not null. Sorry, 80 null, not null. 80. Who is giving the value? Who is giving the value? C. That's it. This is over. Yes or not? That is over. Again now come back. So that is E1 is over, E2 is over, E3. What is the way? B to C, it is moving, right? B to C, it is moving. 2C is there. 30 plus 2. What is the value? Okay, it will become 32. Who is giving this one? B. Over. Yes or not? Yes or not? Okay, that is also over. E3 is also over. See here now. 0 plus 0 plus 10. Okay, 0 plus 10 compared to this one, this is more actually. More, 10 is more. That's why no need to change. Now what is the updated value? 0. Okay, null is there. Again B value, you check it. You check the B value. What is the value? 2C. Got it? Yes or not? Again you check it. Again you check it. C value you check it. 32B. Yes or not? C value you got 32B. Again D value check it. 80C. Okay, so that is what it is reducing. Okay, that is what we are doing, the relaxation. If you continue further, please observe, this is the shortest path actually. This is the shortest path, you got it here. But if you continue further, if you want to verify, if you continue further, if you are getting negative values, nothing but this, if you are getting negative values, it indicates very clearly it is a Bellman-Ford negative cycle. Okay, negative cycle graph. Understood everyone? Negative edges is there. Negative edge cycle. This one consists of negative edge cycle. So that is the reason why I wanted to show you this is a negative edge cycle. This one consists of negative edge cycle. Okay. So if I continue round 4, nothing but I value is equal to 4. When I do, what is the value you will going to get it? I will show you. Let's see this one. Even. C, what is the value of C? 32. 32 minus 38. What is the value you will going to get it? Please observe here. 32 minus 38. Minus 38. What is the value you will going to get? We will going to get to value that is minus 6. Who is giving this one? C. Yes or not? C. Yes or not? That is what. If you again, that is okay. Even is done. This is the one. Even is done. Again E2. Let's come back to E2. 32. See here, everybody observe it. Here E2. Okay, here 32 plus 40. What happens? 40, 50, 60, 70, 72. You are getting 72. This is over. 72C. Yes or not? Updated. Again, that is over. E2 is over. E3. You check it. E3 now. E3. B to C. We are moving, right? Minus 6 minus 30. Minus 6. Yes or not? See here, everyone. B to C. See, observe here. So minus 6 is there. Minus 6 plus 30. What is the value you are going to get it? Minus 6 plus 30. Minus 6 plus 30. That is 24. 24. Who is giving this one? B. Who is giving this one? B. Okay. That is also over. E3 is also over. This one. 0 plus 10. Same thing. It will keep like this. This is minus 6 only. Now you update the values. Now you will going to update the values. A value is what? 0. Null. B value is what? That is B value. See this minus 6 and C. Minus 6 and C. Again C value, check it. That is 72. Yes sir? No, sorry. 24. 24B. This one. Not here. This one. Okay. Again C value, check it. C value is over. D value, check it. D value 72C. See here. when you are getting a negative value, it understands very clearly, it says that very clearly, this cycle is called as negative edge weight cycle. Okay na, negative edge weight cycle. So if you continue further and further, it will keeps on changing. Okay, it keeps on changing, you will not going to get the proper path value. So that is the reason why only do 3 rounds, do 3 rounds. This is your shortest path. Okay, 3 rounds is more than enough. Value changes, keep on value changes here. If you further continues, this is what we call it is negative edge weight cycle. Okay, so this one you have to understand. So this is the one important thing in the Bellman-Ford algorithm, negative edge weight cycle. This is a negative edge weight cycle. So further, if you move further, what happens? Now it is 6c, again after that it will become minus 14c, after that it will become minus 2, like that. If you keep on continue, see here, if you keep on continue, what is the value you will going to get it? See here, if you keep on continue, you will going to change. Here also changes comes, up to infinity it will goes, up to infinity it will goes, up to infinity it will goes. Okay, so finally what it will, nothing but what happens here, basically observe here, A is not depending on B. Please observe here, A is not depending on B, but C is depending on B. Again B is also depending on C, and D. Okay, so D is also depending on C. This is what you have to understand. If it is such kind of cases, automatically you will going to find the negative edge weight cycles. So this is one more important in the Bellman-Ford algorithm. This is all about Bellman-Ford algorithm. Very simple and very highly important things we did today. We can able to see it. Okay, once you go through Dijkstra's algorithm, it's very important, and you check it. So the difference between, one more important, few lines I will going to write it here, and I will going to wind up here. Okay na, few lines I will going to write here, and I will going to wind up here. So what is that? Few lines is nothing but first one, line number 1. Let's say line number 1. To find single source shortest path, in positive edge weight graph, we will use Dijkstra's algo, because it will give correct answer. Okay, it will give correct answer always. Okay, second point number 2. If graph contain at least one negative okay edge, one negative edge weight, then Dijkstra's may fail. So we should go to Bellman-Ford, which is correct always. Okay, number 3. See, number 3. If graph contain negative edge weight cycle Bellman-Ford algo will find if it reachable. So this one, what is this reachable, is nothing but, suppose example, go back here, please here, observe here, this is what if suppose example, if the edges are here, okay, so A B C D, again E F G, these things are not connected, think like that, these things are not connected, automatically it will going to ignore that, it will say that very clearly it is not connected, it is not the part of this particular graph, yes or not, this graph is different, this graph is different, think like this, okay, connected like this, think like this graph is different, this graph is different, that is what exactly we are talking here, this one. If graph contains negative edge weight cycle, Bellman-Ford algo will find it if it is reachable or not, okay, so reachable or not, it will going to identify this one, that is what exactly you have to know. Again fourth one, if graph contain negative weight cycle, that is what we discussed right now, negative weight cycle, then Bellman-Ford algo will give correct answer, will give correct answer, which are not part or depend on negative edge weight cycle, otherwise answer is infinity, that is what already I shown this one, okay, so it will become a negative edge cycle, so automatically if you further continues, it will become infinity is nothing but what, undefined, so this is what you have to understand, these things are very very important, I given the best one, okay, so this is one thing you have to understand very clearly, so this is all about Bellman-Ford, okay.